then? A is 4. 4 what? Degrees. Radians. Okay. Where could 4 radians be? Is it 1, 2, 3, 4?
No,
Third sector.
it's a little past the half.
Yes, a little bit past halfway. Because halfway is how many?
3.14.
Yes, 3.14-ish. And this far would, well, if this is almost 3, then 4 is not going to be all the way down here. So it's going to be somewhere in here. And to sketch that angle, minimum requirements, I'll show you the minimum requirements. The initial side, standard position means the initial side is always this positive x-axis out to the right here, horizontally. And then where it ends, and an arrow telling me which direction you went. That's sketching an angle. Part B, we're going to do -3. Okay. Well, we're going to start here. We're going to go this way. And we're going to go how far?
A little bit before.
A little bit before halfway, because halfway is 3.14 pi. So almost halfway, not all the way, so just a little bit off. There you go, there's -3 radians. Coterminal angles. So we've got this this angle that we don't really need to look at, but it's there. 7 pi over 6. We're going to find 2 angles that are coterminal, which means cos equals the same place, that place being the end, the terminal side. So here's one. I can follow this all the way around. Go right there. Then okay, go all the way to the angle itself, 7 pi over 6. Go past it, all the way around. Right? Once I get here and I keep going, how far do I go to get to here? 2 pi, a full rotation. So then I went in the positive direction, right? So I added 2 pi, 7 pi over 6 plus 2 pi, a full rotation. But I need a common denominator, right?
Yep.
Yeah, agreed. So 6, and this will be
12.
12 pi over 6. So 12 pi over 6 plus 7 pi over 6 is 19 pi over 6. We can go the opposite direction as well. We can go back a full rotation. Which really means only this much is the actual angle that we measure. So how far did we go back? 2 pi. We're a full rotation. We're a full rotation to get from that terminal side back to that terminal side. So we'll take 7 pi over 6 and subtract 12 pi over 6. So we get negative 5 pi over 6. Find the complement of the supplement. Okay. So, let's just say vocab review. Complement.
The angle that will make that 90 degrees.
But we're in radians.
Oh,
So it'll make,
it
it won't make 90, right? It'll make what?
um,
Pi over 2 radians. Okay, that's complement. And supplement would be adding to
1 pi.
pi. Half rotation or quarter rotation. Okay, so we have 3 pi over 4. Let's just look at a picture of 3 pi over 4. pi over 4 to get to pi over 2?
No.
If we said that we could, we kind of could, but that angle would have to be negative. The complements are both positives. They're positive. Okay? So no complement exists. No complement. But a supplement. Could we get a supplement? Could we go to pi? Yeah? Yeah. We have a little bit more to go to get to pi. And how far would that be?
Pi over 4.
Yes, pi over 4, right? You can look at it this way. 3 pi over 4 plus some angle needs to be pi. So that angle must be pi minus 3 pi over 4. So x must be equal to, this would be 4 pi over 4. So pi over 4. Just need to find two angles that add up to make first pi over 2 and then pi. If you're in degrees, 90 and 180. The hardest part about that is maybe common denominators. Rewrite each angle and radian measure as a multiple of pi. What it means by saying a multiple of pi means don't write it as a decimal. Don't put in your calculator pi and then see what decimal comes out. We're going to write it as a multiple. So the angle is negative 270. We're going to convert that to radians. Let me remind you about converting things. If I have 473 inches, I'm going to convert that to feet. Then how do we do that? Divide by 12, because we know that there is 1 foot for every 12 inches. What about 2 feet for every 24 inches? Is that true? Will that work? Sure. 3 feet for every 36 inches. 4 feet for every 48 inches, and so on. Well, it doesn't really matter. As long as we have some kind of a ratio where the numerator and denominator are equal, it's called an equivalence ratio. We're going to multiply by this ratio so that we cancel out those inches, and we get 473 essentially divided by 12. And whatever that is, I guess so we'll erase that. That's the deal. We want to multiply by a ratio that takes us from what we have to what we want. We're going to go from negative 270 to, just from degrees, to radians. So we need a certain number of degrees to radians that are equal. Pi radians is the same as 180 degrees. Cancel the degrees. We get negative 270 pi over 180. Or negative 3 pi over 2. And you don't have to write radians. I only wrote that so you understand that that's the units we're trying to get to. B. We're going to multiply that by pi radians over 180 degrees. Degrees cancel. 144 pi over 180. Which simplifies to 4 pi over 5. Want to convert this to degrees, so we just want to go the other direction. So we're going to multiply it by something that will cancel out those radians. Right, radians. And take us to degrees. Still, pi radians is the same as 180 degrees. So there's our conversion. We cancel out the radians. Also, they have a factor of pi that's going to cancel out. And so we get 7 times 60 is 420 degrees. B. 180 over pi n. Radians cancel radians. Factor of pi cancels. 15 times 3, negative 39. Convert the angle measured from degrees to radians. So we're getting more. Convert degrees to radians. The only thing is, when we get done with this one, we won't have a multiple of pi like we did here, like negative 3 pi over 2 and 4 pi over 5. We'll just have some decimal answer. Still, we want to go from degrees and wind up with radians. So 180 degrees to pi radians. So negative 216.35 times pi. Divided by 180. Negative 3.77.
Six.
6?
Sorry.
7, 6?
Yes.
7, 6.
No,
No,
777.
3.776. This is 4 decimal places, isn't it?
Three.
It says 3.
Yes, it does.
Oh,
Zero.
I am embarrassed. 54. Convert degree to radian. 8 pi over 13 times 180 over pi. Pi's cancel. Apparently this is not going to come out nice. Nice round number. 8 times 180. Divided by 13. 110.769. What was next? You don't know.
73.
Oh, you do. That was well.
Wow.
Picture. Whoa, what's happening? So talking about the nothingness over there. So, what is this? What is this called?
The radius.
How long is it?
7
7 meters. This picture tells us that. Something's 32. What's this called?
The arc.
The arc length is 32. Is there a formula that relates the arc length to the radius in some way?
Yeah.
What is it?
That S symbol A. No.
Theta
Yeah. R.
r. Okay. trying to find? Find the angle in radians. In this equation, what does this have to be measured in?
Degrees?
No, radians.
Oh.
That's kind of where radians comes from in the first place. Anyway, we're going to solve for theta in radians, then we can just take s divided by r, and that gives us theta. Theta is equal to s, which is 32, over r, which is 7. There it is. There's your angle in radians. Okay, find the radian measure of the central angle. What we just did, right? The arc length is 10, the angle, or let's see, yeah. The arc length is 10, and the radius is 22, and so the arc length is 10, and so the angle is going to be s over r. That's 10 over 22. That's 5 over 11. About a half a radian. Give us an angle that is 60 degrees. And an arc length, no, a radius that's 9 feet. Arc length equals theta times radius. So we just do 60 times 9. Is that right? No, you're not paying attention. You. Like, Kaylee.
I was going like this.
Oh, you were just
Yeah.
knocking out some
Yeah.
invisible.
Yeah, I didn't mean yes.
Oh, okay. You sure?
Yes.
Okay, then what? Why is this not right?
Because that's
not
the
It's not in radians.
Yeah.
How many radians is 60 degrees?
I over 3.
3 pi. 3 pi feet. Somewhere around 9 feet. More than 9 feet. 83. Now we're okay. It is in radians. We have. Pi over 3. 2 pi over 3 is our angle. Our radius is 27. Oh yeah, arc length equals 2 pi over 3 times 27. This is a 9 pi meters. Okay, pass your homework, please.
How would you put that on? This is weird.
Okay, we're in section 4.3 today. We're skipping over 4.2. Yeah, we're going to come back.
Are we really?
We are going to come back.
Thank God.
Okay. Well, we're going to be learning about right angle trigonometry.
Yay. I love
Right
that.
triangle trigonometry. Kids, triangle. Triangle because it has 3 sides, 3 angles. It's a right triangle because it's got a right angle in there. So if we were using this as theta as opposed to using this as theta, and we look across the way at this side, we call that side the what side? The opposite side. And we call this side adjacent side, because adjacent means
Next to.
next to, that's right. Opposite, adjacent, and this side is,
Hypotenuse.
why is it the hypotenuse?
Because it's across from the right angle.
It's across from the 90-degree angle. What if there's not a 90-degree angle in a
It's
triangle?
not a right triangle.
Well, it's not a right triangle, but then which side is the hypotenuse?
The one across from the one you know?
The what?
The longest side.
The longest side. The longest side is the hypotenuse.
Wait, what if it's anyone's triangle with these two sides?
Then there's nothing. Well, they're both hypotenuses. This depends on who you ask.
Okay. Alright.
There is no longest side in that case. Alright. Hypotenuse, opposite, adjacent. Okay. So the word trigonometry comes from metry, meaning measurements, measuring things, measuring what? Measuring triangles. Trigonometry is the measuring of triangles. One way you can measure triangles that's really useful, because no matter how big this triangle is, say, I mean, this triangle could be this size on this board, or you could draw a circle right here, and that circle could represent the entire Earth, so that the triangle would be huge, right? But what remains the same, if these angles are the same, are the ratios of all the sides to all the other sides. For example, if you take the opposite over the hypotenuse side, no matter how big this triangle is, whether it's this size or is so big that it encompasses the whole Earth, it still has the same proportion of the opposite side to the adjacent side, as long as this angle stays the same. And this opposite over hypotenuse ratio has a name. Do you remember what this name is?
Same.
Cosine.
It's the sine.
Sine.
There's another, I mean, how many ratios can we make with three sides?
6.
6. We can take this over that one, this over that one. We can take this over that one. We can take all the reciprocals of all those. So we get the adjacent side over the hypotenuse. That has a name.
Cosine.
The cosine is the name of that ratio. The opposite over the adjacent. Tangent. Okay. Now, like I said, you can make those three, and then you can flip them all over. So you can take the hypotenuse over the opposite side. The cosecant. Cosecant on an angle is the hypotenuse over the opposite side.
Is this one secant?
This one's secant. The hypotenuse over the adjacent side is the secant. Next one's cotangent. That's the adjacent side over the opposite side. Those are all definitions. If we, number 2, as an example. This is a triangle. This is theta. This is 13 and this is 5. So, this is theta, then what side is this?
Opposite.
Opposite, and this is the hypotenuse. And so you could tell me 2 trig ratios right off the bat. Without even that third side, you could tell me which 2.
Sine.
Sine, opposite and hypotenuse. Cosecant, hypotenuse and opposite. The sine of this angle is the opposite over the hypotenuse. The cosecant is 13 over 5. The hypotenuse over the opposite, or the, hypotenuse over the opposite. Can you tell me the cosine at this moment?
No.
Not yet, we need
The
the adjacent side, so we'll call it A for adjacent. How do we find that third side? Pythagorean theorem. We take this side plus this other leg squared equals 13 squared. A squared equals squared minus 5 squared. Squared equals 13 times 13. What? 1?
169.
Okay. 169. 25 a squared equals 144. So a is 12. I'm going to take the square root of both sides. This is 12. So now we know the adjacent side. The adjacent over the hypotenuse. 12 over 13. Secant. 13 over 12. Tangent. What's the tangent?
Opposite over 12.
5 over 12. Opposite over adjacent. Cotangent. 12 over 5. But let's look at this a little differently. If all they tell us is that sine of some angle is 9 over 5, no, that's 5 over 6. Is that number? How could we use that fact to find all the other 5? The other 5 trig ratios. Get the opposite hypotenuse, so you can do what with that? So that would imply that we have a triangle, right? Can we draw a triangle?
Yeah.
Right, we're like, maybe this is the angle. And so now we can fill it in with what?
Opposite hypotenuse.
And so the opposite side would be
5.
5 and the hypotenuse then that's 6. And then we would have to find this guy here, Pythagorean theorem. Let's call it a, the adjacent a squared plus 5 squared equals 6 squared. So a squared equals 36 minus 25. So a squared equals 11. And a equals the square root of 11. Now we know the sign, now we can find the, tell me anything. Ryan, tell me something.
The reciprocal of 5 over 6.
Okay?
I don't know which one that is. I have no idea. That's the hypotenuse over the very opposite.
Opposite. What's it called?
Oh,
Anybody?
Cosecant.
The cosecant. Okay, great. Give me another. The tangent is. Okay, so now we have to talk about. Let's talk about space shuttles. The men and women who sent the space shuttle to the moon. They sent the rocket actually. The shuttle wasn't. They sent a rocket to the moon. They didn't have calculators. They had something called. Anybody remember? Slide rule. It was like a ruler. A ruler with 2 sides and a middle piece. It could slide in and out. And by lining up these little hatch marks, I don't know how to use a slide rule, so I'm going to explain it to you. But somehow by lining up these marks, they could do some pretty complicated calculations. But something they couldn't do was divide by the square root of 11, or by the square root of 3, or by the square root of 2, or any irrational number. Okay? So, but what they could do was they could take an irrational number and divide it by an integer. So that changes around a little bit so that they could do that calculation. So can we multiply the denominator by something so that it's no longer the square root of
Yes.
multiply by the square root of 11. So we'll multiply this by the square root of 11. We get 5 times the square root of 11 over 11. That's something they could do. They could do that with their slide rules. Okay? And now we get to keep doing it today. But they also sent a rocket to the moon, so I think we can forget
So.
believing that it will work.
tangent is 5 square root of 11 divided.
That's right.
What if you have a number 2 times the square root of 11? Like if it was 2 times the square root of 11?
Let's say we had 3 over 2 times the square root of 11. Still multiply by the square root of 11. Right? And now what square root of 11 times square root of 11 is 11.
You just get 22.
So you get 22. So you get 3 root of 11. How about the cotangent?
Square root of 11.
Good. If we go back here and we take the reciprocal of that, then we don't have to do the rationalizing of the denominator. We just have square root of 11 over 5. And then if we have, I'm going to do this cosine, that's going to be the square root of 11 over 6. And the secant is going to be 11, which will be 6 root 11 over 11. Get the sine and the cosecant, cosine and secant, tangent and cotangent.
Where is the secant?
Right here.
16.
Now we're going to develop together as a math-loving race of people the trig ratios for these special angles. Angles that we use a lot, like 30, 45, and 60. First we'll do 45, because it's the easiest. 45 degrees in a right triangle. Well, that means that this is 45 as well. Okay. We need to start out somewhere. We need to say one of those sides is something. We can't, just because it's 45 and 45 doesn't mean anything about the sides. So we got to set one of those sides to be something. So set to be 1. And so what else do we know then? Now that I said that, the adjacent side's 1 as well. Can we find this side now?
Yes.
Square root of 2. A squared plus b squared equals c squared. Square root of 2. So the sine of 45 then is 1 over square root of 2. Which 45 did you use? You could use either one. It doesn't matter, right? Because they have the same opposite side. It's exactly the same. Same hypotenuse as well. So 1 over the square root of 2, which we have to,
Do the
thing, and that thing is called rationalizing the denominator.
Yep.
So we get root 2 over 2. And then the cosecant of 45 is, so what? Root 2 over what?
2. 1.
Root 2 over 1. One way we can do it, you just go back here and flip this guy over. Root 2 over 1. If you flip this one over, 2 over root 2, we multiply by root 2 over root 2, we get 2 root 2 over 2, cancel root 2.
I just thought we were doing cosine.
Oh, cosine. Cosine of 45 is also 1 over root 2, which is also root 2 over 2. Same thing. So the secant will also be root 2. Tangent is right, 1, good, great. Cotangent of 45 equals also 1 is the reciprocal of tangent. Now if we draw this triangle, make this one 60, and this side 1, that's enough. That's enough information to fill in all the pieces. What's this angle?
30.
30. Right. Can you tell me any of the other sides? Let's do this. It's not like that 45 degree angle one, but if we draw a mirror image of this triangle over here, how big would this angle be then?
6.
How big would this angle be?
30.
So how would this angle be? Also 60. So what kind of an angle is, or what kind of a triangle is that? Equilateral triangle, which means equal sides and equal angles. So how long is this?
1,
How long is this?
2.
So how long is this?
Whoa.
Get in, get in. Can we find this side? Answer is yes. Right. Let's call it A. A squared plus 1 squared equals 2 squared. A squared equals 3. A equals the square root of 3. 4 minus 1, 3 square root. Square root. Now we don't need all this mess. Look at that.
Wait, so if you just double the bottom one, you'll get the hypotenuse?
Always.
Always?
Always. If you double the short leg of a 30, 60, 90 triangle,
Oh.
you'll get the hypotenuse.
So it has to be 30, 60, 90?
Yes.
Okay.
Because only the 30, 60, 90 has a 60-degree angle whose sine, I should say cosine, not the cosine of 60 is what? Come on now. Do your homework. And order. The cosine of 60? It's 1 over 2. Okay, so pay attention to what that means. If we have a triangle, and it's a 30, 60, 90 triangle, then the cosine is always 60, which means that the ratio of the adjacent side to the hypotenuse is always 1 to 2, always 1/2. So if this is 5, this is 10. If this is 6, this is 12. This is 100, this is 200. It's always that. That's exactly the kind of measurements we're talking about here. It's just a ratio of one side to the other. If this is something, this is 2 times that on a 30, 60, 90 triangle. Okay? And that's part of the use of these. So the secant of 60 degrees is 3 over 2, no, 2 over 1. 2. The sine of 60, that's root 3 over 2. The cosecant is 2 over root 3. It's 2 root 3 over 3. Tangent is opposite over adjacent. Root 3 over 1. Cotangent equals 1 over root 3 or root 3 over 3. Okay, here's the bonus. Since we did all the stuff for 60, we've taken all possible ratios of all the sides for 60 degrees. So we must have also done it for 30 degrees because it's in the same triangle. We took all the sides over all the other sides. And so in here, we've already done the work for 30. Like the cosine. The cosine of 60 is the adjacent over the hypotenuse.
It'd be the
It's the
opposite over the
it's the opposite over hypotenuse for 30. So the cosine of 60
is
the
the
sine of 30. Okay. And if this is the sine of 30, this must be
cosine.
what? The cosecant. Okay, the sine for 60 is opposite. The opposite side is root 3, but for 30, root 3 is adjacent. So it's adjacent over a hypotenuse. So it's the cosine of 30. And if that's the cosine and this is the reciprocal, this must be the secant of 30. Root 3 over 1, that's opposite over hypotenuse, but for 30 it's adjacent over hypotenuse, and and that is the cotangent. And this must be the tangent. So that brings up an interesting identity. In any triangle, this isn't just special to 30 and 60. It's true of any two angles in a triangle together, in a right triangle together. If this is theta, can we find this angle? It's possible. At least we know that we should be able to find it. Well, this angle and this angle should add up to what? 90, because this has got the other 90 taken care of. So you need to add up to 90. So how would I find this angle?
Just subtract.
90 minus that angle. 90 minus theta. So let's actually I'm going to write this again. Because for 90 minus theta, this angle, what's this side? The opposite side. But for theta, it's what? The adjacent side. And for theta, this is the opposite side. And for 90 minus theta, it's the adjacent side. And for both of them, this is the hypotenuse. As well. Yeah, that's nice. So now, any two angles that are in a right triangle together have this kind of a relationship, where the sine of one is the cosine of the other. The sine of 90 degrees minus an angle is equal to the cosine of the angle, of the original angle. You can see that here. The sine of 90 minus theta, that's opposite over hypotenuse. Well, that's the adjacent for the theta. Adjacent over hypotenuse, that makes the cosine. The cosine of 90 degrees minus theta, that's the sine of theta. The tangent of 90 minus theta is the cotangent of theta. There's three of them. There's a total of 6, right? You see? A total of 6. Sine of one is the cosine of the other. The cosine of one is the sine of the other. The cotangent is the tangent. Tangent is the cotangent. The secant is the cosine. So I won't write all 6 of them down, but they are all 6 of them on page 279. So, there you have them all. I'm just going to go over some identities. These ones, reciprocal identities, we've already talked about. They say that let's say the cosecant, start out with that. The cosecant is equal to the reciprocal of the sine. The reciprocal of the sine, 1 over the sine. Which means that the sine is the reciprocal of cosecant. They have this reciprocal relationship. We have the cosine. I guess we should say the secant. We're going to kind of keep it organized. Secant of an angle is equal to the reciprocal of the cosine. And the cosine is equal to the reciprocal of the secant. And the tangent is the reciprocal of the cotangent and vice versa. So we got the tangent of theta is equal to 1 over the cotangent of theta. And the cotangent of theta is equal to 1 over the tangent of theta. Then we have these quotient properties. motion properties are specific to tangent and cotangent. Tangent of theta is equal to the ratio of the sine to the cosine. The sine and the cosine, they have this, sine, cosine, and tangent have this relationship with each other. Okay? And so do the cotangent, cosecant, and secant. They also have a relationship together. I just want to show you this. I want to prove it to you. I'm going to prove to you that the sine over the cosine is equal to the tangent. So the sine is what? How do we get the sine in a triangle? Opposite over the hypotenuse. So the sine over the cosine is equal to the opposite over hypotenuse. That's the sine. What's the cosine? The adjacent over hypotenuse. When we divide fractions, multiply by the reciprocal. Hypotenuse over adjacent. What happens now? Cancel the hypotenuse, get opposite over adjacent. And what's that? The tangent. The cotangent is equal to the cosine over the sine. This last one's called the Pythagorean identities. Okay. Let's make up the first one together. To do that, I'll draw a little picture. We'll make this angle theta. We'll make the hypotenuse 1. We make this the opposite side, and this is the adjacent side, of course, that's what they are. Then, if we take the opposite over hypotenuse to get the sine, take the opposite over the hypotenuse is just 1. So we just come out with the opposite again. The sine of the angle is equal to the opposite over hypotenuse, so the sine of the angle is the opposite side when the hypotenuse is 1. So that's just the sine of theta. What do you think the adjacent side would be? The cosine of theta, right? Is the adjacent over hypotenuse comes out to just be the adjacent side, so the cosine. So you have the sine here, the cosine here. Then we have the Pythagorean identity, or the Pythagorean theorem, which says what? Right? A squared, cosine, squared, plus b squared, sine squared, will always be equal to 1 squared. Okay. And since all these ratios are the same, no matter how big these triangles are, the cosine of an angle plus the cosine squared plus the sine squared of an angle will always be equal to 1. Now let's take this Pythagorean identity, and we'll divide both sides by the cosine squared. Which means that we divide this by the cosine squared, divide this by the cosine squared, divide this by the cosine squared. So what's cosine squared over cosine squared? 1. What's sine over cosine? Tangent. And so sine squared over cosine squared would be the tangent squared. Tangent squared. What's 1 over the cosine? It's what? Secant. So secant squared. One plus tangent squared equals secant squared. We could do the same thing, only we divide by the sine squared on both sides, and we'll get the cotangent squared plus 1 equals the cosecant squared. solve for anything. We're not trying to find theta. We're not trying to do anything like that. We're just going to show that this side is the same as this side. Lots of different strategies here, different ways to approach it. But it's all going to come down to these identities. We might use the Pythagorean identity, we might use one of these identities, we might use one of these identities. But as we look at this, we see that two things multiply together, and one thing comes out. So somehow we need to combine these together and create one thing out of them. But I don't know what cosecant times tangent is. Right? There's not an identity for that. So if you're multiplying things together and you're not sure how it's supposed to come out, try using those reciprocal identities and quotient identities. Like, what's the cosecant in terms of sine and cosine? Reciprocal of sine. So it's 1 over the sine. Okay. What's tangent in terms of sine and cosine? It is 1 over cotangent, but if we put it in terms of sine and cosine, if we get everything kind of boiled down to the same things. Sine over cosine. What happens now? The sines cancel and we get 1 over cosine. What's 1 over the cosine? And so secant is secant. See? A little math candy. What?
What?
If anything were math candy, that's math. It's not that hard. It's kind of fun. It works out. Right? Doesn't really do anything for you exactly. Neither does candy.
Candy does too.
What does it do?
It tastes good. No, it doesn't. I can't eat that
Did you just say
math.
that tastes good?
Yeah, it tastes math good. Gift of the soul. Right?
If you eat too much math, you'll puke.
No, not me.
So candy does taste like
There's a little candle that makes ghost peppers. This is what that is.
No, not ghost.
Yeah. Where you think it's awesome and then you die. Yeah. Those
You're a good
peppers are kinda
storyteller,
hot.
Anna.
Your
Thank
kids are gonna be
you.
so fun.
What?
I said your kids are gonna be so fun.
My kids are fun.
You know, math candy.
I know what they are.
Are they?
Yes.
Do you play dolls with them? Like house?
They're not really into that yet, but I will.
Oh. Okay.
Will you force math onto them and
Yes!
make them math?
Oh my god. You're gonna be like 3rd grade when you're learning this stuff. You're gonna be math.
Oh, they already know this stuff.
Do they really?
Yeah.
Yeah. They're not even into dolls and they know this stuff. That's the norm.
Did you know it was them who made videos?
Yeah.
Oh my gosh, you guys can find me?
Okay, let's take a look at this one.
Oh my goodness.
Oh. How do two fractions become one thing?
You cross cancel and it becomes nothing.
What the heck is wrong with you? That's when you're multiplying.
Oh,
They're added together.
sorry, I thought they were multiplication.
So they're added.
Oh.
So you need common denominator.
Wow, this sounds not about
This
you.
is our homework.
So, what's going to be the common denominator?
Sine.
Yeah, you just got to multiply those two denominators together.
Let's go tangent.
Huh?
Cotangent. What? What are you talking about? Use cosine over sine.
But they're
Cosine
not.
over sine. Oh, this? Yeah, we can make that cotangent and we can make this tangent. But then they don't go together to make these two things. That's not a bad thought. Right? They don't mesh at all. But if we get common denominators, add them, then we have one thing, just like this is one thing.
Yeah.
Okay? So, what do we multiply this by to get our common denominator?
1 over, I don't know.
Multiply this by sine, so multiply this by sine.
Yep.
So, sine over sine. So up here we get sine squared. over sine, cosine.
Oh,
How many exasperated sides do you have people? Did you keep adding?
Yeah, no kidding.
It's like almost unlimited
We
supply.
keep them compressed all day until this class.
I believe it.
I just get so tired.
So multiply this one by cosine over cosine. Cosine over cosine. So then we get sine times cosine. So we'll multiply by cosine. So we get cosine plus cosine squared. Sine squared plus cosine squared.
Isn't there a formula?
Isn't there?
I couldn't tell you.
It equals 1.
It equals, this equals 1. Whoa.
What?
One over sine.
Hold on. How does that equal 1? It's a formula?
It's one of those identities. It's one of them Pythagorean identities.
Hold on, I need to figure
I
this.
wish I had time to copy this too.
Sine squared.
What?
Getting angry.
Okay, this is like, we could write this as 1 over sine times 1 over cosine.
But how does that equal 1?
No, sine squared plus cosine squared is 1.
It's just a formula.
It's an identity.
It just is.
Look,
Because
cosine
we
squared plus
figured it
sine
out.
squared equals 1.
Where did that come from?
From here.
I wrote them all down and it's not in here.
Well, obviously you
Didn't
did
write
right
them all
now.
down. There it is.
You did right all.
What's 1 over sine? The cosecant. What's the 1 over cosine?
Secant.
Then-
Oh my goodness.
So are you gonna cut our homework in half?
Why would I do that?
Because you like us and don't want us to die.
It's too much for us to process in one thing. We do 52 first. It's another one of those other ones.
Oh my god. Every time you try to do this one, this is math candy. Not.
I don't say not that. I can say not like that. The early 90s.
We weren't even alive then.
I know. You're young. I get it. Let's brag about it. You got 2 things multiplied together and 1 singular thing comes out. So,
You do math.
you do some math.
1 over tan
Yeah.
1 over the tangent.
It just happens.
times. Hold on.
Okay.
1 over cosecant.
1 over the cosecant.
Delaney, do the whole problem for us.
I need to. I need to know how to do
That's
this.
not gonna help.
That didn't help.
Aw.
Here's the thing.
She just threw her pen.
All of these.
That's not
Rage quit.
But wait.
All of these can be written in terms of sine and cosine.
Cotangent is the cosine over the sine.
Okay?
What?
No,
Why
shut
did
up.
I make this a pen? Hey, now I'm gonna bring your head into a garbage can.
Look,
That's not very nice.
No,
One
not
over
there.
1. And then they cancel and you get cosine.
cosine over sine is cotangent.
Why are you putting those?
Love you
notes
too,
up on the
lady.
phone?
I
So,
wrote
yes.
that one down.
Times the sine over 1. They're all in your book.
Are they?
They
They are.
are they? Yes. And sines cancel, cosines